Good afternoon, my name is Josh Hall, and my EEL 6825 pattern recognition project was a Markov chain analysis of political competition during the decay of the Roman Republic over 2,000 years ago. The inspiration for this project was from Dr. Wu's discussion of the Iliad and modeling social events in our pattern recognition course. The conflict I examined was a series of escalating struggles in the late Roman Republic, which I modeled using a Markov chain using theoretically known data points. As a bit of historical background, the events depicted took place between 133 and 30 BC. They were driven by increasing economic inequality and immiseration of the Italian people. Rome had been very successful in its wars, but this somewhat paradoxically did not improve the living standards of its people. This led to political conflict. The populares and optimates are a useful lens to depict the parties that represented the interests of the lower classes versus those of the aristocracy and Senate. These were nowhere near the modern, disciplined Democratic and Republican parties we see today, but there were definite loose coalitions who would advocate opposing policies, and individual politicians might drift from one camp to the other through their career. I think the words of the historian Appian sum up the period fairly well, though. The sword was never carried into the assembly, and there was no civil butchery until Tiberius Gracchus, while serving as tribune, an elected official, and bringing forward new laws, was the first to fall victim to internal commotion. As the evil gained in magnitude, open insurrections against the government and large warlike expeditions against the country were undertaken by exiles or criminals or persons contending against each other for some office or military command. Thus, out of multifarious civil commotions, the Roman state passed into solidarity and monarchy. So basically, this whole chain began when a populist leader, Tiberius Gracchus, tried to pass legislation. It looked like he was going to win, but he broke a few rules to get there. So the Senate decided to put an end to his program and organized a mob and had him murdered. A few other situations like that continued until eventually rival political leaders began to actually field armies against each other, like these two men, Marius and Sulla, rivals before the more famous Julius Caesar. Sulla on the left, or on the right, represented the Optimates faction, Marius on the left, the Populares. Sulla ended up defeating his enemies and ruling as dictator of Rome, enacting extreme persecutions against his opponents in a program called proscriptions. This series of wars continued until they basically burned out, and the adopted son of Julius Caesar, Octavian, declared himself Augustus and emperor of Rome. So at that point, the Republic was no more. This problem had several challenges related to data collection and how to represent the data. It had a wide array of sources, classical histories and literature, some even from eyewitnesses of the events depicted, but they mostly have incomplete data, or if they were eyewitness events, tended to carry some sort of bias with them. After all, if Julius Caesar's writing his memoirs, he's not going to write about all the bad things he's done himself. He's going to write about how he was a clever general. Some other sources included modern popular histories to help orient to the events, educational resources to gain a more systematic approach, and academic publications to gain more insight into the situation. One of the key problems in this project was how exactly to quantify the situation. These are kind of soft events, not firm measurements. So what I did was I built a timeline of events. I initially pursued an effort to automate event selection, which was less successful than I hoped. So I had to abandon that effort in order to categorizing events by hand. I selected key variables such as military advantage, popular advantage, elite advantage, tactics, preemptive action, and then coded an event as a popularis victory or an optimatis victory. So a negative value for one of the data entries would be a optimatis entry or advantage, and a positive value would be a popularis advantage. Just to clarify, tactics might reflect some sort of cleverness on the battlefield, whereas preemptive action reflected more a broken precedent. So not so much a battlefield trick, but say breaking the law to win an election, or murdering a political opponent, or on the most extreme end, marching with an army against the state. I stored this data in an Excel sheet for easy updating and easy parsing into arrays in my actual code. So some of the algorithms included in this program included a Markov chain. In theory, I know all the points mu for data, so I don't have to concern myself with their probability just yet. More sophisticated learning methods would consider the probability of an event configuration. The values x represent the outcome of an event. Those form a chain all the way down to the final encounter. I trained my network using maximum likelihood with log likelihood, so that whole set of products is difficult to take a gradient of and find the maximum for. So if you take the logarithm, product becomes a sum, and it becomes much easier to train against. So I developed parameters for my probability event nodes this way, and I used scikit-learn for this procedure. My model also used a sum product message passing algorithm, which in a more complicated situation could drastically reduce the number of procedures to execute in a code. I use this to generate a marginal probability value. So you divide a network into variable and factor nodes. Factors can only have variable nodes and vice versa. You can build messages from variables to factors and factors to variables, and use all of those to calculate a marginal probability. I relied on someone else's code to do that with modifications for this case and the vast number of variables involved. So that work was based off of code by Jessica Stringham. Maximum likelihood estimation used the scikit-learn library. Some modifications and data to draw in. I had function-based probability values, a sigmoid function. Data from the table pulled into pandas. Node and variable names pulled in as well. This would have been very difficult without pandas in the file. It was written using the Spider IDE in Python. As a quick analysis, I selected the first 58 events as a training set. So the Gracchi brothers up to Caesar's civil wars. I developed estimated parameters off of this. I selected events 58 through 75 as a test set. So the events of Caesar's civil wars up to the victory of Octavian at Alexandria, ending the civil wars. The training set had an accuracy of about 0.83. The test results were calculated with a marginal probability of each node, so I did not have to know the historical results ahead of time, and I found an accuracy of about 0.89. The parameters are published here. I ran for a full analysis and a simple analysis. You may note the relatively high bias. In the full analysis, only tactics and preemptive techniques and technically popular advantage outweighed the bias. So there's a lot of noise and unconsidered factors here. But it makes sense that tactics and preemption would secure victory. This whole sequence of events was set into place by people breaking the rules because other people had broken the rules before them. It should also be noted that there's a bias in the historical record itself. An author is less likely to pay attention to the tactical excellence of a general who lost, opposed to the tactical excellence of a general who won. So losing generals may have actually been quite clever, but simply unlucky, and their efforts were not recorded in as much detail as those who won. This concludes my presentation, and I hope you enjoyed the discussion.